Okay, hello and welcome everyone. So in this video, I'm going to do a walkthrough of 5 problems from the problem set. If you haven't already got the problem set, I'm going to be quiet in a second so you can take a screenshot or whatever and work on these problems here. So it's going to be these first 4 questions. So question 1, 2, 3, 4, and 5. What did I do? Oh, I released that. Oops. Okay. 5. Right. All right. So I'll leave this for a second. You can pause the video, take a screenshot, whatever you want to do to be able to work those problems. All right. And then we will talk about them. So for the first one, Anne has an income of $50, spends her income on popcorn and beverages. Popcorn costs $10, beverage costs $5. The store where Anne buys the beverages has a special deal. After you bought 6 beverages, you can buy each beverage for $2.50. Draw Anne's budget set. Suppose the following preferences exist for Anne, where beverages and popcorn are going to enter into the utility, where 1 beverage plus 3 popcorn is going to be Anne's overall utility. What's the optimal bundle? And I'll read through the rest later on. All right, so here is, I've got them here. Here is that problem. So we have a budget constraint. We have a budget constraint where the price of one of the goods changes, so we have a kink to it. The way that I would recommend approaching these is to first write down the intercept for whichever price doesn't change. Second, find the expenditure to reach the kink point. Third, find the additional consumption in both directions from that kink. And then you can find your maximal, you'll find the actual coordinate for the kink, and then you'll find how much you're going to be consuming of, in this case, beverages. All right, the other thing that I've done is I've said, well, look, if the price of beverages is 5 and the price of popcorn is 10, then the slope of the budget constraint is 1/2. If the price of beverages is $2.50 and the price of popcorn is 10, the slope of the budget constraint there is 1/4. So we're going to go from relatively flatter to even more flatter, right? Steeper than to flatter. Yeah, I've got 1/2 rather than -1/2. I've got 1/4 rather than -1/4, right? This should be -1/2. It should be -1/4, but we know that we're going to be comparing the slope of a budget constraint to the slope of an indifference curve. They're both going to be downward sloping, so they're both negative, but then we cancel both of those negative signs. So sometimes I'm just going to report this in absolute value, and I might not say that I'm doing it in absolute value. Why? Because we know that we're going to be canceling the sign anyway. So it's not something to get too worked up about. All right, so here is the graph. The first thing that I recommend doing is plotting the point for the vertical intercept for the price that doesn't change. That's popcorn. We have $50 available, popcorn costs $10, so I can buy 5 popcorns. So I'm going to write this here. That would be my total expenditure. Oops, I lost the bottom of my bottom here that I was that's not what I wanted to do, is it? And that's even worse. Marginally better. All right, so what I want to do, and probably if I didn't even say something, most people wouldn't notice, but I might as well. So this is not going to be costing $20. This is going to be costing $30, right? So this costs, that's terrible. All right, so this costs $30. Pretend that $20 not there, because it's going to be $20 plus $30 is the 50 I have. All right, whatever. So next thing we want to do is we want to find how much it costs us to reach the kink point, right? We said after we buy 6 beverages, the prices change. Well, beverages cost $5 until the price changes. So my expenditure on beverages, P1 times X1 is going to be $30, right? 6 times the price of 5, $30. Alternatively, here's my income, right, that I'm devoting to this amount. So $30 divided by 5, that's this intercept. I don't know. That's not an intercept, but that's what this is. All right. Anyway, so we got to this point. We found how much we expended to get to here. Now we have $20 remaining. I can spend the remaining $20 on beverages at a price of $2.50 each, which means those $20 divided by $2.50 gets me 8 more beverages for a maximal amount of 14 beverages. Or I could spend those remaining $20 on popcorn and buy 2 more. That's what brings me up to the 5 here, right? So if I just wanted to buy at the kink, I could buy 6 beverages. That would cost me $30 plus 2 popcorns. That would cost me $20, and that would exhaust my budget, $50. Right? So we got it. Okay, so that is the budget constraint. That is how I would build it. Next thing we are told we want to do is we want to say, all right, well, Anne has these weird preferences. These are perfect substitutes preferences. The slope of the slope of the indifference curves, the MRS, is going to be 1/3. Yeah, -1/3, fine. But anyway, they're going to have a slope of 1/3, which we're going to compare to the slope of the budget constraint. And we recognize, well, the slope of the budget constraint is going to be 1/2 at the top, 1/4 at the bottom. 1/3 lies between those. So that's going to give us this interesting situation. I'm going to draw my picture really carefully. So here I'm trying to draw my picture pretty carefully. The budget constraint, right, has a slope of 1/2 up here, actually -1/2, because it's going to be the price of beverages here is 5 divided by the price of popcorn, 10. That's a half, right? Slope of the budget constraint down here is going to be 250 divided by 10. That's 1/4, okay? Yeah, it could be -1/2, it could be -1/4, as long as we call this -1/3 for the slope of the indifference curves, or we could just report everything in absolute value, or we could just know these things are downward sloping, just draw the picture with an approximate slope. Anyway, so here is going to be indifference curves with a slope of 1/3. All right, if I draw these indifference curves with a slope of 1/3, what I'm trying to do is I'm trying to determine where is going to be the point where the highest possible indifference curve crosses the budget constraint. Turns out it's going to be up here. So the indifference curve with a slope of 1/3 is going to be flatter than this part. It's actually going to be a little bit, it's going to be a little bit steeper than this part. However, we're still going to, because we're up this far, we're going to miss down here. So I don't know if I drew the picture 100% like to scale. Clearly I didn't, right? But the point is, like, your highest possible indifference curve is going to hit up there. All right, suppose we don't trust the graphical representation. You're like, well, maybe you drew it. No, whatever. So suppose we want to verify with utility. You could do that. And so I've done this down here. This is part B. First off, I'm saying, yeah, the MRS is going to be 1/3. Oh, how did I know the MRS is 1/3? Well, the marginal utility of beverages is the coefficient on B. The marginal utility of popcorn is the coefficient on P. So MUB divided by MUP is going to be 1/3, right? Which is flatter than the top, but steeper than the bottom. My picture is arguing that it's an alley solution. It's an all-Y solution. We're spending all of our money on popcorn to max, or Ann is anyway. Suppose we just wanted to verify that, like, what would be the other candidate? Well, maybe we want to spend all our money on beverages. All right, fine. Let's compare the utility levels. So if we buy 5 popcorns, my utility from this is going to be 5 times 3 is 15. Or if I buy 14 beverages, my utility is going to be 14. So I've actually got higher level of utility if I spend all my money on popcorn. And so indeed, we've shown that the all-Y solution is correct. All right, so what I would do for one of these, where you have the kinked budget constraint, and so I'd build it, like I said. First, stipulate the intercept for the price that doesn't change. Second, find your expenditure to the kink where the price does change, then find out how much you can afford of both goods going in either direction. And then when you're doing the maximization portion, if it's a perfect subs, I would draw the picture. I'd compare the slopes to the slope of the indifference curve to the slope of the budget constraint. And then to be absolutely sure, yeah, I'd probably check the utility levels. It's low cost. I'm just going to enter in the bundles and compare the utility at the two places. All right, question number 2. Question number 2, that was on this sheet, so I have to go back and read it. Question number 2, this is from Deidre McCluskey's microeconomics book. And so it's a really good book. Available for free, PDF, so just Google Deidre McCluskey and you'll find that book. So anyway, in a household that receives charity in the form of $100 in free housing per month is equally well off if it receives $100 in cash payment. Support your claim. Well, I mean, look, cash is fungible. The voucher's not. You're better off with cash because you can spend it on both goods, whereas the housing voucher can only go to housing. So the answer's got to be you're better off with cash. No. So the answer here is no, you're not better off with, you're not equally well off with the housing voucher as with the cash. You're better off with cash. What's the picture? Well, taken right from Deidre's text is this picture right here, McCluskey, 1985. So let's see. Our two options are 1, $100 used for either good, or 2, $100 used for housing only. Our vertical intercept initially is M over P0 for other goods. Income divided by the price of the other goods. This is how much I can buy of other goods. Here's my income divided by the price of housing. Now what's happened is if I get a free $100 that I can spend on either good, that's going to give me a new budget constraint. So my income's change is going to be M plus 100 divided by the price of housing. And then over here, M plus 100 divided by the price of other goods. That shifts out my budget constraint, right? The numerators of my intercepts increase when income increases. Good, so I can consume all these extra things. What happens if I get the $100 only for housing? Well, what that's going to do is it's just going to shift the bottom portion of the budget constraint, meaning the vertical intercept, the other goods intercept in case 2, where the $100 is applied to housing only, is still right here. because I don't have any additional income to spend on other goods. So the maximal amount of other goods I can afford is still right here. So the maximal amount of other goods moves along this area right here, and then she's shaded in lost opportunities. Why? Well, the person who would have the cash would have the ability to buy everything I've shaded in here. The person who doesn't have the cash and only has the housing voucher would not be able to buy those things. So my comment is, consumer prefers cash as it expands the choice set. More choice is better. Imagine really flat indifference curves hitting the lost opportunities area. I'm dodging my microphone, sorry. And so you could think of really flat indifference curves that would cross up here. So maybe there's some higher indifference curve, some high flat indifference curve that the person with the cash would be able to achieve by buying a bundle that's along here, whereas the person with receiving the $100 for housing would not be able to consume these bundles, right? Okay, so that's the logic. All right, so Anne is always willing to trade Y for X at a constant rate. Specifically, is always willing to give up 1/3 units of X to get an additional unit of 1/3 units of Y to get additional unit of X. Draw a picture of Anne's indifference curves. Oh, I realize I drew the wrong picture, didn't I? I drew the wrong picture. How do you know I drew the wrong picture? The slope of the indifference curves has to be 1/3, which means I want to go, this is rise over run, I want to go down 1/3. So I need these things to be flatter. But I'm so far into this video, there's absolutely no way that I'm going to change that. And so this is the wrong picture. Let's pretend that doesn't exist. How can I get rid of that? I don't know if I can get rid of that. Here's how I can get rid of that. Just like that. That was not what I wanted to do to get rid of it. Here's how I can get rid of it. That's the wrong picture. All right, so the slope of the indifference curves, what's the correct picture? Let's screw up anything else? I don't think so. So the right picture is going to be, we are going to go down 1/3, down 1/3. What's going on? You're giving up 1/3 of a unit of Y for every additional unit of X, right? Giving up 1/3 of a unit of Y, or I'm giving up 1 unit of Y to get 3 units of X, right? Think of rise over run. The numerator is like the rise, the denominator is like the run. All right, good. And so we're going to have downward sloping parallel lines with a slope of -1/3. So the MRS is going to be -1/3. If you were thinking of a utility function that would generate that, it'd be like a perfect subs-utility function, such as u of xy would be equal to 1x plus 3y. That would do it, because the marginal utility of x would be 1, marginal utility of y would be 3. MRS is going to be mux over muy, 1/3. Okay, and again, here, I wrote this with a negative sign here. I wrote this with a positive sign here. That's by design. Why? Because we know these things are downward sloping, right? And so the sign ultimately is going to cancel when we compare it to a price ratio. Okay. Anyway, Anne is willing to trade Y for X at a constant rate. Specifically, Anne is willing to give up 2 units of X to get an additional unit of Y. Now this picture should be right. It is. Draw a picture. So this is right, rise over run, 2 units of Y to get an additional unit of X, rise over run. So the rise is I'm giving up, losing 2. The run is gaining 1, right? Losing 2, gaining 1, rise over run. That's going to give me the slope of the indifference curves, right? I'm giving up 3 units of Y to get an additional unit of X. So my MRS is going to be -2. So these are downward sloping lines with a slope of 2, right? So I said downward sloping lines with a -2 because the MRS is 2, right? Here's my sign. Here's my comment here. Everyone knows the curve has a negative slope, so sometimes we suppress the sign. Note also, comparing margin rate of substitution to the price ratio, if you report them, as long as you're consistent, you report them both as negative, those signs cancel, or both as positive, don't worry about it. So that's what this is. All right, next thing is make up a utility function that exactly represents Anne's preferences. There's lots of them because you could take a monotone transformation of the one that I've got here, but I like this one the best. This is going to be the simplest, so it's going to be 2x plus y. How do we know this? Because let's take the partial derivative of this utility function with respect to x. That'll give me mux, that's 2. Partial derivative with respect to y, that's going to give me muy, that's 1. So the MRS indeed is going to be 2. Suppose Anne has income of $24. The price of good X is 2. The price of good Y is 3. What's Anne's optimal choice? Well, look, the price ratio is going to be 2/3, PX over PY. The indifference curves are steeper. Steeper indifference curves mean we're going to have our Alex solution. Sure enough, I've drawn this picture here. We'll have our Alex solution. So that's because the slope of the indifference curves are 2. The slope of the budget constraint would be 2/3. So the highest indifference curve, how did I not draw the budget? I don't know. Maybe it got lost, whatever. So you draw a budget constraint here with a slope of 2/3, good. And then the optimal bundle is going to be our all x solution. So here is my comment for my budget constraint. The budget constraint would be 2x plus 3y is equal to 24, solving. The vertical intercept of my budget constraint would be 8. So I actually want my budget constraint to extend from here to here. Like if you're thinking about how this should draw, I should go from here to here. All right, my horizontal intercept was 12. Yeah, so I want my budget constraint to drop in like that. Hey, I wonder if I can, let's see. I always wonder about the usefulness of, hey, that's good. That's great. Look at that. Don't have to stop the video, don't have to start over. Beautiful. Okay, so this is our Alex solution, and because I solved for this point, we know how much x we're going to have. 12 units of x. And how much y? None, because this is our Alex solution. The goal is to find the highest indifference curve that you can afford that crosses your budget constraint. All right, number 5. Anne is willing to trade y for x at a constant rate, specifically willing to give up 4 units of y and get additional unit of x. Draw several indifference curves. These are going to be downward sloping straight lines with a slope of 4. Right, so it'd be like this picture, but I'll put a 4 here and I'll put a 1 here. Right, that's going to be this. Make up a utility function that represents and preferences for the same reason above. For the same reason that this was give up 2 units of y to get 1 unit of x. Mux was 2, Muy was 1. Similarly here, the Mux is 4, Muy is 1 because we're giving up 4 units of y to get additional unit of x. The MRS is 4, which means Mux is 4, Muy is 1. That's this. Sorry, I wrote this right here. All right, suppose Anne has 24 units of income available. Hey, those aren't just units, those are dollars. The price of good X is 5, the price of good Y is 1. What's Anne's optimal choice of X and Y? Well, we'll compare the slope of the budget constraint to the slope of the price, slope of the budget constraint to the slope of the indifference curves. The indifference curves have a slope of 4. Budget constraint has a slope of 5, right? 5 px divided by py. Yep, so budget constraint has a slope of 5. Indifference curve have a slope of 4, which means the indifference curves are flatter. When the indifference curves are flatter, that gives us our alley solution, right? So all y, so the MRS is 4, less than 5. This is our alley solution. Here, alley is going to buy 24 divided by the price of good y, which is 1, so 24 units of y. So that's what this is. You see at the bottom, I've got question number 6 here. That'll be in the next video. So hope you enjoyed the video. I think I'll leave the comments that you can ask questions or ask questions over email or whatever. But hope you enjoyed.